Welcome to integrals of rational functions. So recall if we have an integral like, let's do the integral of 2x plus 3 over x squared plus 3x minus 5 dx. So this is a rational function. This one is set up perfectly for u substitution. So that numerator is the derivative of the denominator. So where the numerator is equal to the derivative of the denominator, then the problem is essentially set up to do u substitution straight away. Right? So the integral is set up for simple u substitution. In this case, we would set u equal to the x squared plus 3x minus 5. Du would be precisely our 2x plus 3 dx. And our integral of 2x plus 3 over x squared plus 3x minus 5 dx becomes just the integral of 1 over u du, which is natural log of the absolute value of u plus c, or natural log of the absolute value of x squared plus 3x minus 5, whole thing plus c. So this is a quick integration, quick u substitution, but not all rational functions take this form. So for another example, let's consider the function or the integral of x cubed minus 5x squared plus 3 divided by square root x dx. So this does not fall into the previous category, right? And we have two options to solve this. So option 1 would be to rewrite square root x as x to the 1/2, and then just do the division. And then once we've done the division, then integrate. So that's option 1. We're going to take option 2, which is kind of a strange u substitution. So for option 2, we are going to set u equal to the square root of x, or x to the 1/2. Then we have that du is equal to 1/2 x to the negative 1/2 dx, or 1/2 times 1 over square root x dx. We also have, if u equals the square root x, then x should be equal to u squared. So we can just replace the entire problem with u's instead of x's. So we have x is equal to u squared. The other piece of information we have, again, 1 over square root x dx would be equal to 2 du, since du is equal to 1/2 of 1 over square root x dx. From here, we can go ahead and plug in. So we have the integral of, the original was x cubed minus 5x squared plus 3 over square root x dx. This becomes the integral of u squared cubed minus 5u squared squared plus 3. Then over that, whoops, sorry about that. All right, plugging back in. Then 1 over square root x dx was 2 du. Or this becomes the integral of, let me give myself more space, 1 moment. All right, so we are looking at the integral of 2, whoops, sorry about that. The integral of 2 times u squared cubed becomes u to the 6th. And we have minus 5u to the 4th plus 3. And then that's all multiplied by du. That 2 is just going to come along for the right. And then u to the 6th would go to u to the 7th divided by 7. Then we would have minus 5u to the 5th divided by 5 plus 3u and then plus c. Or this is 2/7 u to the 7th minus 2u to the 5th plus 6u plus c. Plugging back in, our u is equal to the square root of x, or x to the 1/2. So we have 2/7 x to the 1/2 raised to the 7th minus 2x to the 1/2 raised to the 5th plus 6 times x to the 1/2 plus c, otherwise known as 2/7 x to the 7/2 minus 2x to the 5/2 plus 6x to the 1/2 plus c. So this is a not so pleasant way of doing what we could have done previously. If we did our just simple do the division, x to the 1/2, x cubed over x to the 1/2 is x to the 5/2. Integrate that, we would raise the power to 7/2 divide by 7/2. X minus 5x squared over x to the 1/2 would be minus 5x to the 3/2. Raise the power to 5/2, divide by 5/2. And then we would have plus 3x to the negative 1/2. We would raise the power to x to the 1/2, divide by 1/2. So that's an alternative. This is a more complicated way to get that using u substitution. But say if we had square root of x plus 3 in the denominator, that would be harder to cancel out, and this technique would be very useful. All right, let's take a look at one more. So let's consider the example integral of x cubed minus 4x squared plus 3x minus 1 all over 2x plus 5 dx. So in this case, we certainly are not in the case that the numerator is a derivative of the denominator. And so from here, we will go ahead and simplify. So we're going to simplify by doing the division. So in order to do x cubed minus 4x squared plus 3x minus 1 divided by 2x plus 5, we can set this up as long division. So we have x cubed minus 4x squared plus 3x minus 1. We are dividing by 2x plus 5. We are just going to focus on the first term when we do the division step. So to do 2x times what equals x cubed? That would be 1/2 x squared, or in other words, x cubed divided by 2x is 1/2 x squared. Multiplication step, 1/2 x squared times 2x is x cubed. Then 1/2 x squared times 5. We are looking at a plus 5/2 x squared. And then we are going to subtract these. So we have minus 4 minus 5/2. That's minus 8/2 minus 5/2 will be a negative 13/2 x squared. From here, we want to know how negative 13/2 x squared divided by 2/2. That will be negative 13/4 x. If we multiply these out, negative 13/4 x times 2x will be negative 13/2 x squared. We would have had a plus 3x to consider. Well, now we have a minus 13 times 5 is 65/4 x. And then we are going to subtract. So we are looking at 12/4 x plus 65/4 x. We'll go up to 77/4 x. Pull down our minus 1. 77/4 x divided by 2x will be a plus 77/8. Do our multiplication, we'll have 77/4 x plus 77 times 5 should be 385, and then over 8. Finish off with our subtraction. This becomes negative 1 minus 385/8 would be a negative 393/8. So we have minus 393/8 times 1/2x plus 5. That's our remainder. So it's multiplying by 1 over our denominator. So at this point, we can then go ahead and take our integral. So what we get is the integral we were trying to take. So we were looking at the integral of x cubed minus 4x squared plus 3x minus 1. All over 2x plus 5 dx. This is precisely the same thing as taking the integral of 1/2 x squared minus 13/4 x plus 77/8 minus 393/8 times 1 over 2x plus 5 dx. So the first chunk of this integral is just basic integration using the power rule. So we can split this into two integrals. we have 1/2 x squared minus 13/4 x plus 77/8 dx. Then we are subtracting off 393/8 times the integral of 1/2x plus 5 dx. So this first integral, we will just have 1/2 and then x cubed divided by 3, raise the power, divide by the new power. Then we have minus 13/4 x squared divided by 2. And then we would have plus 77/8 x. And then we would have a plus, I'm going to say plus C1. For our second integral, I'm going to give myself more space. So for our second integral, we then would have minus 393/8 integral of 1/2x plus 5 dx. For this integral, we might as well use u substitution. So we will go ahead and set u equal to 2x plus 5. And we therefore have du is equal to 2 dx, or dx equals 1/2 du. So we have the integral of 1/2x plus 5 dx is just 1/2 the integral of 1/u du. I still didn't give myself enough space. I apologize. From here, we have 1/2 natural log of the absolute value of u plus c, I'm going to say plus c2, since I already have a c1 involved. And then plugging back in u, we have 1/2 times the natural log of the absolute value of 2x plus 5 plus c2. So we can go ahead and plug all of this back in. We had that our integral was equal to 1/2 times x cubed over 3 would be 1/6 x cubed. Then we had minus 13/4 times x squared over 2 would be minus 13/8 x squared. Then we had plus 77/8 x. Plus C1. And then we had minus 393/8 times this integral we just found. So times 1/2 natural log of the absolute value of 2x plus 5 plus C1, sorry, plus C2. And then C1 is a constant, C2 is a constant. If we just set C to be C1 minus 393/8 C2, we wind up getting then that our integral is equal to 1/6 x cubed minus 13/8 x squared plus 77/8 x minus 393/8 times 1/2 would be minus 393/16. Natural log of absolute value of 2x plus 5, and then plus c. So this is not the most pleasant integration during long division with polynomials. This can be complicated, annoying, and give us not very pleasant numbers. And then we still have u substitution at the end, even when we've already worked our way through the long division. But we can do the integration of a rational function that didn't look very pleasant. Next up, let's consider the integral of 1/1 plus x squared dx. So this one, u substitution will not work. we can't do division because there's nothing to divide into. So there's no simplification. U substitution does not apply. But this is a key integral to be aware of. So note that the derivative of tan inverse of x was equal to 1 over 1 plus x squared. Thus, what we wind up getting is that the integral, I'll do this on the next page. We get, therefore, that the integral of 1 over 1 plus x squared dx is equal to tan inverse of x plus c. So this is a very special case of a rational function that happens to perfectly fit that tan inverse derivative. So watch out for rational functions that are actually inverse trig derivatives. So anytime you have of a rational function, or also even if there are square roots involved in the denominator, it could still be an inverse trig derivative, and therefore we could take the integral just using inverse trig.